This lesson is a follow-up to the previous lesson about the converse of the Pythagorean theorem. So instead of just determining whether a triangle is right or not right using this converse, we will be able to determine, based on only 3 side lengths, whether a triangle is right, acute, or obtuse. To review the Pythagorean theorem, it states that if a triangle is a right triangle, then a squared plus b squared equals c squared. In more friendly terms, a and b are the legs of that triangle, and c is the hypotenuse, which in a right triangle is the longest side. It's going to be important to note that we will be referring to C as the longest side much more often in this video because acute and obtuse triangles do not actually have a hypotenuse. That term is exclusively for right triangles. So the converse of the Pythagorean theorem is stating the reverse of the Pythagorean theorem. So it says if a squared plus b squared is equal to c squared, if the sum of the squares of the legs in a triangle is equal to the square of the longest side, then a triangle is a right triangle. So just to review from our last video, we are going to make sure we understand when a triangle is a right triangle. So if it's a right triangle, then a squared plus b squared will always equal c squared. And again, c is that longest side. So given these 3 side lengths, 11 centimeters, 60 centimeters, and 61 centimeters, I know that 61 is the largest value here, so that is the longest side. This is going to be C in my theorem. So I'm going to plug in what I know. Let's switch things up a little bit. I don't have to write 11 squared plus 60 squared equals 61 squared. 11 squared and 60 squared can be flipped. So I'm actually going to write it like this. 60 squared plus 11 squared is equal to 61 squared. These shorter sides, their order doesn't matter. As long as you are squaring them separately and adding them together, the order when we add does not matter. So you can write this formula either way. Okay, so calculating using order of operations. In order of operations, exponents come first. So 60 squared is 60 times itself, and that is 3,600. Plus 11 squared, which is 121, and that's equal to 61 squared, which is 3,721. So now we're going to add the terms on the left side together. 3,600 plus 121 is 3,721. And when comparing it to the right side, or c squared, we can see that they are definitely equal to each other. So since a squared plus b squared does equal c squared, we know that this is a right triangle. These 3 side lengths, when combined together, will always form a right triangle. Now let's move on to some new information here. In acute triangles, if a triangle is an acute triangle, meaning all of the angles are less than 90 degrees, then a squared plus b squared is greater than c squared. Again, a and b are shorter sides, and C is the longest side. So in our example with 35, 45, and 55 inch side lengths, I can already see that 55 is my longest side. That is going to take the place of c in our formula. So let's determine if a squared plus b squared is greater than c squared. So 35 squared plus 45 squared. And then we are not sure whether this is equal to, less than, or greater than 55 squared. So that's why I put the question mark here. We are not sure if they're equal yet. So 35 squared is 1,225 plus 45 squared, which is 2,025. And 55 squared is 3,025. Adding the terms on the left together, adding a squared and b squared together, I am getting 3,250. And we need to compare that to c squared, which is equal to 3,025. I'm seeing that a squared plus b squared is greater than c squared. So in this case, and with all three of these side lengths, you will always form an acute triangle. And just to visualize this here, let's say, and this is estimating, this is in no way exact. Let's say this side is 35 inches. So that means my next side is going to be a little bit longer than that. A little bit longer. Let's call this 45. And then you can see that the base when I form this triangle is going to be longer than the 45 side. So this will be 55. And again, this is an estimate, but you can see that none of my angles appear to be right or obtuse. This is an acute triangle. Okay, now using the converse of the Pythagorean theorem to determine if triangles are obtuse. If a triangle is an obtuse triangle, then a squared plus b squared is less than c squared. A squared plus b squared is less than c squared, and just so we have it on our screen, a and b are the shorter sides, and c is the longest side. This will always be true. Okay. So given a 5-foot side length, 12-foot, and 15-foot side lengths, I am seeing that 15 is the greatest value, so it is the longest side. This is C. The other two side lengths can be A or B. It does not matter the order. So let's set it up. Shorter sides squared, 5 squared plus 12 squared, may be equal to 15 squared. Order of operations says exponents go first. 5 squared is 25. 12 squared is 144. And it's possibly equal to 15 squared, which is 225. Adding the terms on the left side, 25 plus 144 is 169. And when we compare that to c squared, which is 225, I am seeing that a squared plus b squared is actually less than c squared. So since this is the case, a squared plus b squared is less than c squared, these three side lengths will always form an obtuse triangle. And again, just to visualize, I'm not saying this is a reliable way to solve your problem, but let's say this is my 5-foot side length. And I know that the 12-foot side length is a little bit more than double. Let's make that obtuse angle here. So this is my 12-foot side length, and the longest side is going to be a little bit greater than the 12-foot side length, and that's 15. Again, drawing is not a reliable way unless you have exact perfect measurements to determine whether a triangle is right, acute, or obtuse. The most reliable way here is to use the converse of the Pythagorean theorem like we've been doing. All right, so just a couple more example problems before we end our lesson. These are the type of problems that you will see on your assignment. I'll ask you to tell me whether each triangle is right, acute, or obtuse given the three side lengths. So in our first example, we have side lengths of 20 millimeters, 30 millimeters, and 40 millimeters. First step, always identify the longest side. If you set up the converse of the Pythagorean theorem and you place one of the shorter sides as C, this will not work. So it's super important that the longest side is always where C is supposed to be. And just so we have it on our page, a squared plus b squared is equal to c squared. We're going to C. So my shorter sides are 20 and 30. They're going to take the place of A and B. And my longest side is C. So 20 squared is 400, plus 30 squared is 900, and it's equal to, possibly, 40 squared, which is 1600. Let's add up the side lengths on the left side. 400 plus 900 is 1300. And when compared to 1600, I am seeing that 1300 is less than that. So this means that a squared plus b squared is actually less than c squared. And based on what we know of the other types of triangles, this is going to form an obtuse triangle. If a squared plus b squared is less than c squared, you are forming an obtuse triangle. Let's try out the second example, where I have side lengths of 2 miles, 1.5 miles, and 2.5 miles. Decimals are common side lengths. All right, identifying the longest side, greatest value is 2.5 in this scenario, so this is going to be my C. The other sides are A and B. Setting up the Pythagorean theorem here, 2 squared plus 1.5 squared is possibly equal to 2.5 squared. Using order of operations, 2 squared is 4. 1.5 squared is 2.25, and 2.5 squared is 6.25. Adding a squared and b squared together, 4 plus 2.25 is 6.25. And in comparison to c squared, they are equal to each other. So if a squared plus b squared is equal to c squared, then those three side lengths will always form a right triangle. And there you have it. We use the converse of the Pythagorean theorem to determine if triangles were right, acute, or obtuse. So here are the lesson and assignment details for you all. If you have public questions or would like to have a live meeting with me for help, post in the office hours channel. And if you would like more private help or one-on-one assistance, contact me via email. Have a lovely day.